My name is Paul Leoni. I am an undergraduate junior at George Washington University. I am an agroecology intern this summer in Dr. Tolley's lab, and during the academic year, I volunteer at Karen Gadan's lab at GW to work on different saltwater intrusion projects. My project was the creation of a risk map for nutrient runoff from agricultural fields into the Chesapeake Bay watershed. Chesapeake Bay in the past has had a history of eutrophication, large-scale dead zones where you had a lot of nutrient runoff from agricultural and urban sources going into the bay, creating these harmful algal blooms that eventually led to depleted oxygen levels. And one of the main problems with saltwater intrusion is that as it moves landward, it has the ability to dislodge legacy nutrients within agricultural soils that will eventually run off into the bay. That was the overarching context within which I wanted to design my project. The lab had decided that we were going to go back out into the field to continue that investigation of the correlation between elevation and salinity. And I knew that would be the perfect opportunity to get deep into these agricultural sites and actually get a sense of how can I collect these samples to create this risk map of nutrient runoff into the bay. When we were out in the field doing work with the lab, I took opportunistic water samples from any ditch, puddle, or creek that I found, and I took the salinity reading from those water samples, and from there I was able to quantify a level of risk for each site based on how connected these waterways were to the Chesapeake Bay. You have these policies that have these set limits of maximum nutrient load into the Chesapeake, but saltwater intrusion is going to cause these unanticipated nutrient spikes because as the saltwater moves across the landscape, it's dislodging phosphorus and nitrogen that was left in these abandoned salt-damaged fields and re-entering them into the watershed. And if you have these large nutrient loads coming from agricultural fields as saltwater intrusion advances, then all those efforts need to take into account the areas that should be focused on for decreasing the pollution at its source. I could take that sample, get the salinity reading, and have that be representative of how connected that site was to the larger watershed. It all goes into that profile of better understanding where can we center these management policies that proactively mitigate the impacts of saltwater intrusion on the bay ecosystem. Because of course we can study ecosystems, how they change, but to put it into a context in which it can make positive change, we have to remember the people who are being affected. And I think that this research that is ongoing at the Agroecology lab is doing exactly that, because we're partnering with local farmers to understand the landscape change on their fields, which directly connect to their livelihoods. So if we put this scientific research in the context of improving livelihoods and adapting livelihoods to the future impacts of saltwater intrusion, then we really can unlock purpose behind what we're doing and create a better future, which is going to be necessary as we face these changes.